I'm Nancy Selover. I'm the state climatologist, and I'm affiliated with the Department of Geography or the School of Geographical Sciences, and also with the Global Institute of Sustainability at ASU. As state climatologist, I provide data or climate information, depending on what your needs are. So my email address will be at the end. If you need data or anything, just feel free to contact me. So I'm going to be talking about a current assessment of climate, kind of where we've been, what we think might be happening in the future, and particularly focused on the southwest region and Arizona. But first we're going to look at where are we. So this is for 1981 to 2010, the normals across the country. These are the maximum temperatures in February. And what I really want you to see is if you look at most of these states, you will find that most of them have a very shallow gradient of temperature across them, maximum temperatures in February. But if you look at Arizona, you'll see we have an extremely large range of temperatures in the winter because we have the southwest deserts, we have the Colorado Plateau, we have variable topography, and we in fact have as much climate diversity as California, with the exception of we don't have their coastal climate. Unless the big earthquake happens. So minimums, same sort of thing. Nighttime temperatures, we're very pleasant here in the Phoenix area and the whole southwest Tucson, but we tend to be pretty cold up in the northeast and along the Mogollon Rim. So this is why people come here to spend their February here when they came from up here in Minnesota or from Canada. Summertime, again, we have extreme variability. We have very, very cold areas in the summertime, and then we have extremely hot areas along the lower Colorado River Valley, 110, 115 is a normal situation here in the valley. And even though the basin and range down here tends to have higher elevations and stuff, they still have pretty significantly high temperatures down there. Minimum temperatures, July, we cool off. We have some cooler areas at the higher elevations. Well, everybody goes there in the summer from the southwest deserts. But again, we have a lot more variability just in our state than most of the other states. When we look at precipitation, we don't have as much variability as a lot of those places because we just don't have as much precipitation. And most of that is because of the topography as well. We are in a rain shadow. So in the wintertime, this is the annual precipitation, so it's winter and summer. But most of the year, except for summer, all of our weather comes from the west coast. So we have a cold current down the west coast of the US, and that means the water is not really readily evaporated, which means that even when we have a lot of moisture in the atmosphere, it's really characteristically compared to what happens over in the east, in the Midwest, we don't have that much moisture. So it comes on shore, and the first thing that happens is it dumps its load on the first high elevation it sees, which is the coastal mountains, the Olympics. And then it goes down the other side, the air warms up and dries out, and until you force the air to go back up over the next set of mountains, you're not going to squeeze any precipitation out of it. For us, those boundaries are the coastal mountains in Southern California, and then we have this big rain shadow desert here until we get to the Mogollon Rim and some of the higher elevations down here in southern Arizona. In the summer, that's when most of this land down here is getting its precipitation from the monsoon because we have really nice, warm, juicy water that's coming up the Gulf of California, readily evaporated, so we get precipitation that tends to be extreme. We are a desert. What that means is we get way more evaporation than we have precipitation. But it also means that we tend to have more extreme events. We don't just kind of have, steady rain, but not very much through the course of the whole year. We have extreme rain events, and then we have nothing. Particularly the drought situation in the past 10 years has been very much like that. So extremes to us are not unusual. So it's sort of, we're kind of a little prepared for what might come in the future. So taking a little time series look at this, we've got early part of the last century, we had an extended period of all years drier than the long-term average. And that was why they built Roosevelt Lake and the whole dam system that provides Phoenix with water. Doesn't help much of the rest of the state. And then we went into a really wet period. Whoops. Oh, go back, go back, go back. There. We went into a really wet period, and then we went into another very extended drought. This was almost a 30-year drought in the middle of there, in the 50s and 60s. And then we went back to a wet period, and now we're back into a dry period. So the question is, where are we going from here? I don't know where we're going from here, but I do know that we could have 10 more years of drier than average conditions, which is a problem for a lot of these systems, the ecosystems as well as the populated areas of the state. So we're really not sure, but in the past 1,000 years, we've had 60-year-long droughts, where most of the years looked more like this than like this, where we'd have an occasional wet year interspersed. We're hoping that that's not what happens, but it's certainly a possibility, and we need to be prepared for that. So this was that big dry period. Okay, so we have a third national climate assessment that came out in 2013. So this is put together by the Global Change Research Act that happened in 1990. And the intent was to understand, find out where we were with climate and look at what our risks are, things like that. And this is involving both human-induced as well as natural processes for climate change. And this is supposed to be done no less frequently than every 4 years. Well, guess what? The first one came out 10 years later, in 2000. And then the second one came out 9 years after that. So we're ahead of the game because the next one actually came out this year in 2013. So it actually got done in 4 years. The National Climate Assessment was done in 8 sectors. Alaska and Hawaii had their own sectors, but we have the Southwest and then the rest of the country. So of course the Southwest is the one that we're concerned with. And this assessment's goal was to give us a better ability to figure out where we are, what we need to do, adapt, mitigate, and look at what's going to happen in the environment in the future. And what's different about this assessment than the other two was the other two, they got all these people together, they did all this research, they published this paper, and they all went off in their separate ways. And so the next time they did one, they had to go find everybody, bring them all back together, and get the process started again. So this time, the whole vision of this is going to be a continuous process. So we have a report now. In 4 more years, we'll have another report. But there will be little updates going on throughout that whole period. So the people that were all pulled together to do this are going to be sticking together. Some of the things we found out as we looked at the climate science, that we have more data now than we had before. Quite a bit more data from a lot of different sources, a lot more technology, but also there's just more weather stations that have been put up. We have a better understanding of what's going on, so that leads to increased knowledge. But this is confirming the stuff that was assumed was going to be happening before. So we've confirmed a lot of the models about what they think is going to happen. And we're now also seeing some of the changes that were forecast actually happening at this point in time. It has serious implications for groundwater because we're looking at drier conditions and potential shifts in recharge and rates, things like that, that are going to be certainly an issue for the wildlife. So some of the major findings of this, we look across, this is a look at where we've been again. In the US average, we are getting warmer temperatures in the last 3 decades, and the Southwest is certainly not different than that. We are having much higher temperatures over the last 3 decades. This is also related to drought, so it isn't 100% just because the temperatures are going up. When we have drier conditions, we have fewer storms, we have less humidity in the atmosphere. We're going to tend to have, when we get dry conditions, meaning clear skies, we're going to get higher temperatures. Observed for precipitation change in the US, we look at the average, and it's gotten a lot wetter. That would be really cool, except that's not where we are. We're down here, and you can see a lot of increased precipitation happening in the central US, the northern Great Plains, and the Midwest, and that's great for the farming people. But down here for us, that's not so good because we've had a little bit, we had a wet period here, but then now we've dropped into this dry period. And we're anticipating that this situation is going to follow maybe the trend Hawaii's got, as opposed to the trend that the US average has. Increased volume of rainfall in terms of heavy precipitation events. They're seeing that in a lot of places in the country, they're seeing a huge increase in the number of giant storms, events, 1 or 2 day events that just dump copious amounts of precipitation. We're not really there. We're increasing that a little bit. It would be nice if those events meant more rain. I think mostly what they more mean is just the rain we get is being divided up into a fewer number of days. In Arizona, we tend to get between 30 and 50 days of rain a year. In a wet year, maybe 50 days. So the rest of that is really, really dry. And as I said, we're in a dry climate, an arid region, so we tend to get deluges. So all of a sudden, we have 1 inch to 2 inches of rain in a day, and then not a whole lot, a couple other big events, which is, of course, a problem because with the drought we have wildfires that have caused huge burn areas, and then all of a sudden we get one of these summer thunderstorms that just dumps huge amounts of rain, and we get a lot of flash flooding and degradation of the rangeland and the forests and everything else. Yuma, for example, gets 3 inches of rain a year. 2 of the 3 inches fall usually in one day, not even a whole day. It falls in one storm. So the rest of the last inch happens over the whole rest of the year. So that's sort of where we are. Fortunately, we're kind of used to that. And so we're going to have to make use for that and use that as an opportunity to say what we're experiencing now is probably very much going to be what we experience in the future. So we need to be able to adapt and deal with that we're in this drought. If we get to a wetter period, that's great. That's not a problem. We can handle that. But it's really going to be a problem if we get to a dry situation. And this is a real problem here, projected snow water equivalent. We care about snow because the snow is what causes most of the good things to happen, certainly on the rangeland and certainly in the reservoirs. Is we want that winter precipitation falling as snow where it's held up in the mountains until we need it in the spring when we have grasses starting to set seed and we have wildlife venturing out and looking for stuff to eat. That's when we want to have some of that precipitation melting. But if we've had warmer temperatures, we get less of that precipitation as snow. So by the time spring comes, there's not much left to melt out. And so there's not going to be a lot of water sources. Our months of April, May, and June are very dry, pretty much statewide. So we're not anticipating spring rainfall. We're really hoping that we start to get that runoff and the stream flow and that sort of stuff. When we look at this projection, the very first column, and there actually are 4 columns here in Arizona, and the little tiny one here is the 100%. This is where we are at this point in time, from 1971 to 2000. This is our 100%. And the rest of these periods are looking at what percentage of what we have now can we expect in that period. And it looks pretty dismal for Arizona. I mean, dropping from what we have to only 76% of what we have, we don't have that much in the first place, so that's a major issue. Them dropping even lower to less than 50% by 2041 to 2070, and then down to 12% of it, right? This is a problem. Hopefully this isn't going to happen, but at the moment, this is what is being projected by the models. They're not always right, but if we can prepare for this sort of thing, then if it doesn't happen, we'll be in really much better shape. The good news for a lot of us, but not for the rangeland, is that the precipitation up here on the upper Colorado is not anticipated to be dropping quite that drastically. So that's great for the surface water systems that we pump and do irrigated agriculture. But that doesn't help us to have precipitation falling in other states for the rangeland and the forests. Okay, so the assessment of climate change in the Southwest is available. You should get it. This is an executive summary, and the actual whole report, most of the report is ready. Now, this is something that you probably already know about. I would hope you would all know about this. There are resources for monitoring, adaptation, and mitigation strategies, and they are held in the Department of Interior with the Landscape Conservation Cooperatives and the Department of Interior Climate Science Centers. These are managed by the National Climate Change and Wildlife Science Center. The purpose is to help you do your job by asking you what do you need to conserve the areas that you're looking at, the areas that are of concern to you. So the Landscape Conservation Cooperatives, there's 22 of them. And we have the Arizona one. This is the desert, which covers much of our area. And then this is the Southern Rockies one up here. So these are pretty much the 2 primary ones that we're concerned with. And they have a lot of partners inside all of the federal government agencies, but also in state agencies and the university community as well. And they have projects that they recommend. So if you have a project that you want to be funded, you need to go to the climate science centers when they put out the call for proposals, have your proposal ready and say, here, we need to fund this. We need to fund a project to figure out a strategy for doing what you're trying to do, what you're trying to conserve or change. And then we also see if we can find funding to actually implement that. So there's 2 funding sources that they're working on, and that really comes from the, back again, one more thing. just this past week, I wasn't able to attend this, but the Landscape Cooperative, Conservation Cooperatives had a Climate Strategies Forum this week. So they're looking at strategies to deal with climate change. And I would hope you would all look for the result of this to come out. I'm going to be looking for it to see what they said and what kind of ideas they had and where they're going. But this was an important thing, and I wasn't able to get there. I don't even remember where it was held. And so we have the Climate Science Center. So this is the Southwest one. It's based at Tucson, U of A. It has partners of Scripps, UC Davis, UC, I think it's San Luis Obispo, the Western Region Climate Center, and there's one other. ASU is a second level partner, but those are the primary partners. The USGS, of course, is in charge of these things. And every year, they will have put out a call to all the conservation cooperatives and any of you to come to them and bring them your ideas on what do you think should be funded in the coming fiscal year, what projects, and then they have a little panel, the steering committee that sits there and prioritizes them, and that's how they decide which projects they're going to be able to fund and which they aren't, because of course they don't have unlimited money. No one does. Anyway, so this is the Southwest Climate Science Center in Tucson. You can go see what the stuff they have. There's reports they've done and publications and all kinds of cool stuff and previous projects. And then these are just some references of where I got some of the information that I got and other potential resources that you can look at. And then that's it.
Do you have some questions for Nancy?
We are kind of around that projection, and to a large extent, it's related to the drought. But the question, other question I don't know the answer to is, what has created the drought? Drought's a cyclic thing, and it happens. So warming or cooling doesn't matter. We're still going to have cycles. But that could impact how long those cycles last and how devastating those cycles might be, just how deep that drought gets. We're starting to come out of it a little bit. If you look at the drought monitor, on a weekly basis, they change that and they ask us for input. And we say, this is Arizona. A week of rain doesn't matter, right? I mean, it might be the only rain we get, but if we go a year or two with almost no rain, we don't scream drought. But right now, we're seeing summer precipitation, which in some places was very heavy, and it's causing some improvement. But those are short-term improvements. But we'll take whatever we get. But pretty much it's a drought thing, and how the drought is related to the other kinds of temperature cycles, we're not 100% sure yet.
Another question, Nancy. If I was a wildlife or biology student, I mean, it looks like you're collecting a lot of data, and I would assume that a lot of it might be in some remote areas, but how maybe would I get involved if I was looking for either a career or a summer job through your organization or these types of groups?
Most of the climate monitoring is being done by the Bureau of Reclamation, or excuse me, Bureau of Land Management and the Forest Service. They have a remote automated weather station network that's in all the remote areas, primarily for the purpose of figuring out what's the fire danger. So they take standard meteorological measurements, but they also measure the wood, the temperature of the fuel temperature, yeah. So they have a little temperature sensor they stick into a dowel of wood and monitor that, and the drier it gets, they also have a moisture sensor in there, so they can get a feel for what's the danger, because how close are these trees to being ready to get sparked and go up in flames. SNOTEL is operated by the Natural Resource Conservation Service. So there's a lot of government agencies, federal in particular, that are doing some of those monitoring. We get the data and provide it to anybody else. But the Forest Service, the Geologics, the USGS, any of the Department of Interior agencies would be places that you'd want to go.